Kia ora koutou. My name is Tom Cochrane, and I'm here to demonstrate how our systems model for future agriculture works. The model that I'm demonstrating here is specifically for arable agriculture, so the arable sector, which includes a number of current crops um, being grown around New Zealand. And the purpose of this model was so that we could simulate a number of potential future scenarios of land use change, production yield changes, and values, and also application of technology or management that could impact both on the product value and also on emissions and water, proteins, and calories produced. So a little bit of introduction to this model. So what you'll see here on the bottom left of the model, there's a few buttons here for the model itself. So one is the run button that makes the model run. I have the button that's already highlighted is the go live. So right now it's live. So anything we change here in the model will actually immediately be reflected in the outputs. Reset is basically a button which resets the whole model to the default data. And the default data is from 2021, so fairly recent data. So that means that the data for the um, area of the arable sector, data for approximate specific crops, production yields and values and so forth is from 2021. And then we have a green button here that links to a broader model that includes all the different sectors of the New Zealand agricultural system. So that means dairying, that means forestry, and then others as well. Okay, so in terms of the arable model, which is this one right here, we have three different components. So the first component is the arable production inputs. The second is technology and mitigation options. And the third here are the outputs. So the main purpose, like I said, is to simulate different scenarios. So what we can do here, for example, in the arable production inputs, is we can change land uses. Now, the land use right now is set to the current total arable area, which is 217,000 hectares, and that can be changed in the main model. So if we click on the main model, we can actually change the area of the arable sector because there's obviously you change the arable sector, then that means maybe some dairy sector may diminish or something has to give. So we can change that in the main model. But in this model, we can change the relative contributions of the different types of crops. So for example, if we want to diminish crop and increase maize, we can quickly see that that has an impact on the size of the wheat area versus the maize grain area. And you can play around with this pie chart to establish the percentage of each of these crops that you want to simulate. The other thing that you can change are the production yields. So for example, if you know, in 20, 30 years, you think that you're going to get a much better production of wheat and new varieties and so forth, and you can see what the effect of those could be. You can change that, and you'll see that the production in tons increases, and also obviously the value. So those are things that you can change for each of the different types of crops. And finally, you can also change the value. So right now, these are values for wheat, standard values, but you can increase those values so that we have an impact as well on the sector value. Right? And that's for each of these different types of uh, arable products that we currently produce. The second part here in terms of technology and mitigation options are also very interesting and very useful to play around with if you want to simulate different scenarios. So for example, the first thing here that you see is irrigation needs, and these are average needs for different crops around New Zealand. So wheat we have 295 millimeters per year in terms of how much irrigation is needed. And we can change that value if we wish to be a lower value or higher value depending on what scenarios you're trying to simulate. So for example, a climate change scenario that may result in less rainfall for a certain part or on average in New Zealand, we could assume that there will be an increase in terms of irrigation needs for that particular crop. That's affected by that climate change. The same thing here in terms of irrigated area, we can increase it or decrease it, and as you will see that irrigation area has an effect, obviously, down here in the outputs in terms of the irrigation water use. So that's another value that you can change as well. And you can change in the efficiency of irrigation. So if you increased efficiency, and again, this is from the 2021 value, so if increased by a value of 10%, then obviously you have a reduction in terms of your irrigation water use, right down below. The other thing that you can change is fertilizer application, so nitrogen applied to land, and it's kilograms per hectare, so you can change that wheat value, so in certain situations you may say that, well, we're going to optimize how much fertilizer we put in, going to try and reduce the amount of nitrogen, but in many cases you may not, and that may actually increase. And what that does, it will have an effect on the outputs here in terms of the emissions from nitrogen from arable only, for example. You can increase the efficiency of an improvement in fertilizer use, so there's a certain efficiency and improvement that will have a slight change as well on the outputs here that you would see. All right. This other sector here is in terms of land management and animal feed, and we included this sector as an option so that maybe we have an alternative diet feed for dairy or for cattle, and we wanted to study the effect of that impact. So here we can basically modify the value of alternative feed, and as you see, it has quite a significant effect on the water use and also on emissions, and we can change as well in terms of dairy and see whether that has an effect on emissions as you modify these percentages of feed that you would give to beef cattle, for example. And then you can also change the areas of dairy and beef. So if there's a reduction in dairy, a reduction in beef, so you can immediately see this effect on emissions down here, and obviously on the costs. There'll be some impact on the costs if you're planting more alternative feeds potentially. The other factor that you will see here is the as you change these values, as the brassica and grain area being increased and the dairy number being decreased according to the values that we have in the main model. But again, you go back to the main model, and that interacts very well with that big model, which shows all the sectors. So in terms of the outputs, very simple here. We have calories from cereals, we have proteins from cereals, and we have irrigation water use. We have outputs in terms of carbon equivalents for nitrogen from arable and from total, and also carbon equivalents from methane emissions from animals, and then the value in terms of the arable sector for New Zealand. And so that includes cereal exports, total grain values, and wheat, maize, grain, barley, oats, peas, and then seeds. And so that's a quick overview of how this model works. And again, feel free to try different scenarios, and if you want to reset back to those basic values, you just click reset, and it goes back to that 2021 scenario and the data that's from that scenario. And if you want to go back to the main model, you just click this green button and gets you back to that bigger, broader main model. And this is the main model here, where we have our dairy sectors, our beef, sheep, and so forth. And you can actually change the different areas here if you want, and modify the percentages of those as if you want as well. So you can do it by changing the values or by changing the the pie chart here. And then you have production yields for all those sectors. But again, we have that more detailed model in our arable model that I previously showed you. But the setup is the same: agricultural production inputs, land, production yields, number of animals, value, technology, in this case irrigation for different types of sectors, fertilizer, energy used, manure, and enteric fermentation, efficiency improvements. And again, that's from the baseline year that we're using. And then the outputs in terms of irrigation, food calories, and we have a water quality score here. Comparing that water quality score to the 2021, do we make an improvement or not? And total emissions in terms of our total balance of emissions. So that's the emissions and offsets if you have plantation forests and so forth, and the emissions here for the specific contributions from carbon dioxide, nitrogen, and methane, and the capability to offset that through plantation forests if you want that option. And again, here are the value. So this is in live action, so if we start changing productivity yields or increase milk solid production, you can see very quickly the prices, the export value go up. You change some of the energy requirements, you can see an impact on the carbon emissions here. So this is the green energy development. Sorry, increasing the percentage of green energy development will have a decrease in terms of emissions, and then similarly to in terms of manure management efficiency, will have an impact on methane emissions and fermentation efficiency as well. So these are the things you can play around with and basically see what the effects of different scenarios. So you can build your own scenarios by you know addressing what area that you're changing in terms of different types of production, production yields, number of animals, values, irrigation, fertilizer, energy, and manure management and fermentation efficiencies. And you can see all these different combinations, how those affect emissions, water, export value in New Zealand. So have fun, play around with the model.